and a shock wave, an enormous amount of heat. A large asteroid striking on land would first create a blast and a shock wave, an enormous amount of heat, which would heat the local biosphere. The combination of shock wave, heat, and what's already in the ground and atmosphere anyway would generate nitrous and nitric acid, and the result would be acid rain, we think, as corrosive as battery acid, and so much dust would be kicked up into the air that we would have years or decades without summer. There would be global crop failures. It's hard to think of a pretty explanation of this. I mean, these things are creepy. I'm Greg Easterbrook. I'm a writer. I'm also the author of the June 2008 cover story, The Sky is Falling. I've been writing about the space program on and off for 30 years. The thing that really jumps off the page at you is the discoveries in the last 20 years having to do with the frequency in the recent past of space rock strikes on Earth, of asteroids and comets, and the lookingly ever higher likelihood that this is not some sort of once in a million year event, but something that we should really be concerned with here on Earth. Astronomers began in the early 80s to conduct the first systematic searches for near-Earth objects, and instead of being incredibly rare, which was the assumption, the sky is full of them to a very scary degree. In the year 1980, there were 86 known near-Earth objects, none of which were classed as potentially hazardous. Now there are more than 5,000 such known near-Earth objects. These are just the ones that are close to Earth, with several hundred of them classified as impact risks. The number goes up all the time. It's still with relatively simplistic searches that astronomers have attempted. Astronomers are basically shocked that every place they look near the Earth they find objects where they thought there'd be none. Now you combine this with recent discoveries on the frequency of space rock strikes on Earth in the near past. That's what gets, and then this is when you start having trouble sleeping at night. As recently as, say, half a century ago, if you'd talked to a geologist would have said there's been one major space rock strike on Earth during the period that Homo sapiens is not even Homo sapiens, but the genus Homo has existed. And that was Barrington Crater in Arizona 50,000 years ago, the only time the Earth's been hit in the 4 million years that the human family tree has existed. So it's just not that big a problem. Well, it looks like the Earth has been hit many times more often than that. The key researcher on this, who I talk about in the Atlantic article, is a woman at Columbia University named Dallas Abbott, who 10 years or so was thinking about this problem and had what now seems such an incredibly simple insight, but the simple insights are often the best ones. She had been thinking about the fact that all the crater impact research work had been done on craters on land. And if you count the craters on land, yeah, there's not that many, so probably everything's fine. But 70% of the Earth's surface is water. So if things are striking us from space at random, wouldn't most of them strike the ocean? So about 10 years ago, this woman, Dallas Abbott, started looking for evidence of large impact craters underwater, craters that were caused by some natural factor other than volcanism or something that could happen here on Earth. And in just 10 years, she and a few colleagues have found a lot. They're up to now 14 major impact craters. 14 isn't a big number, but it's a number that a couple of people have found in their spare time in a few years using tools as ridiculously simple as Google Earth. One of them is off in the Gulf of Carpentaria, which is just north of Australia. It looks like there was an enormous object hit there from space in the year 536 AD. That's just 1,500 years ago, not millions of years ago. Within the period that people were building castles in Europe, something big enough to be a threat to human life hit in the water near Australia. Had this object a couple of kilometers across struck the center of Kansas, or if it struck there today, most of the American Midwest would be destroyed. Had it struck the center of Europe in the year 536 instead of hit the water, European civilization probably would have ended at that moment. Dallas Abbott calculates that the impact of this object caused a 600-foot high tsunami. This is at least a dozen times the height of the Indonesia tsunami of 4 years ago. That if it happened happen today. Basically would destroy every coastal city in Asia. Dust and other things kicked up into the air by this impact would have caused several years without summer, and contemporaneous records of the time state that the years 536 and 537, crops failed all over the world, that there was snow in summer, etc. It looks like it was because of space object strike. An object of roughly the same size struck the Indian Ocean a little less than 5,000 years ago and caused a mini ice age and lots of other problems. But because it struck the ocean rather than land, it didn't cause a mass extinction. You go back not too much farther to about 4,800 years ago, around the time of the biblical and Epic of Gilgamesh flood accounts, she finds a crater in the Indian Ocean of an object about 5 kilometers across. That's roughly the size of the object that caused the extinction of the dinosaurs. Now that space rock 65 million years ago hit somewhere in the northern coast of what's now Mexico, and it looks like it put the Earth into 100 years of ice age that killed the dinosaurs and a lot of other land animals at that time too. Some of this is guesswork, but the estimate is that the object or objects that killed off the dinosaurs 65 million years ago looks like there were 2 space strikes in short order. It looks like those objects were 5 to 10 kilometers across, really big. However, the recently discovered Kuiper belt, which is just beyond Neptune, we've already identified over 1,000 objects in that belt that are more than 100 kilometers across. 100-kilometer asteroid, if it struck the Earth, would most likely end all life on Earth. There would be so much energy released to the Earth's surface, not just where it struck, but all of Earth's biosphere would heat so much that most likely the Earth would be sterilized. Sort of adds up to sounding like something that we should do something about, doesn't it? So you'd think that doing an Earth defense mission would be tremendously inspirational, and conceivably, if NASA stops a large rock from hitting the Earth, this would be, let's just say for the sake of argument, the single greatest accomplishment in all of human history. So you'd think that NASA might be interested in trying this, right? But they're not, because in order to do so, they would have to give up on their current ordering of money and funding and positions and privileges. NASA has invested almost nothing in the asteroid threat. In recent years, NASA has spent about $4 million a year. That is, it's a lot to you and me, but it's a pittance by federal government standards, less than 1/10 of 1% of their budget on near-Earth sky surveys, searching for space rocks. They have no hardware whatsoever that could be used to deflect a space rock. They have none in development. They show no interest in putting any into development. NASA's current plan is to spend somewhere between $200 and $300 billion minimum to build a Motel 6 on the moon. And just like with the space station, good luck explaining what it's for. The psychology behind NASA's reaction is, first, that NASA is terrified institutionally of anything that sounds like science fiction. And I sympathize with that. Science fiction is presumed by the public to be ridiculous, and most of it is. So you've seen the Bruce Willis movie where there's an asteroid, I guess it's a comet, and that movie's going to strike the Earth, and half a dozen wisecracking, impossibly good-looking people grab space suits, they get into a spaceship, they roar to the comet, they have fist fights, they have flashback love scenes, they blow up a nuclear bomb. The Earth is... NASA doesn't want anything to do with people saying, my God, we're trying to do a Bruce Willis movie over here. NASA wants to be very cold and detached and scientific. And it also seems like a space rock mission, you would not send Bruce Willis and 10 impossibly good-looking people out to the rock. You wouldn't send anybody. That would be done by automated devices, not by astronauts. One reason you can be relatively optimistic about this threat is it looks like fantastic levels of force will not be needed to deflect asteroids. Your goal of a large rock coming toward the Earth would not be to blow it to smithereens. All you need to do is alter its course by a tiny amount to get it to miss the Earth. And so to do this, first you have to have very detailed knowledge of a space rock's courses. We don't have the technology for that right now, but it's imaginable to build it. And then if you knew that there was an object headed toward the Earth and you knew its course exactly, you would launch a fairly simpler space probe to it. It looks like this would work. The concept has a science fiction-like name called gravitational tractor, but which is not like a tractor beam like in Star Trek, but all objects containing mass project small amounts of gravity. You would build a space probe that just weighs a couple of tons. You would fly it up real close to the space rock. If you had very good information about its course, and you put this space probe a little behind it, a little next to it, a little in front of it, you would, over the course of a few months, very slightly alter the rocks orbit, and then it would miss the Earth instead of hitting it. People at NASA have this worry, everybody has this worry, if we build a space rock defense and billions of dollars go into very impressive looking rockets and great probes and things, and then a century passes and it's never used, that late night comedians will scoff at this and people will laugh. A space rock defense is a form of insurance. And the ideal outcome for expenditures on insurance is that all money spent on insurance is wasted because you don't die, right? And that's the same thing with a space rock defense. If those rockets just sit on the launch pad and never fire, that's the ideal outcome.